This is part 2 of our lesson on equation of a transformed function. So we are on part C. Part C says a quintic function with an inflection point at -6 and 10 that has been vertically reflected and compressed by 20. So things that seem important to me is that it's quintic, it has an inflection point, and it's at -6 and 10. It's been vertically reflected, and it's also been compressed by 20. Now, I think when it says vertically reflected and compressed by 20, that means it's been vertically reflected and vertically compressed, and not that it's been horizontally compressed. So first of all, I need to try to figure out what the type of function is. So it does say it's a quintic. So quintic is something we would call a polynomial function that has a highest power of 5. So I'm guessing this is a power function. So my basic equation here would be c of x equals a times. Now for power functions, they have a bracket with an exponent. And in this case, the exponent is going to be 5 because quintic means 5. And then inside of that bracket, we're going to have our b and our x plus h. And then at the end, we're going to have our plus k. Okay, so this says it has an inflection point at -6 and 10. So that means if I drew myself a little sketch at -6 and +10, that's where the inflection point is. The inflection point on a power function is where it goes from being concave up to concave down, or concave down to concave up. Normally, that inflection point would sit at 0, 0, which means my graph has moved up 10 and to the left 6. So somehow I need to translate that into my equation. So if it's gone up 10, that means my k value is 10. And if it's gone left 6, that actually means we would do plus 6 as our h value. So the inflection point or the vertex is usually -h and k, right? So the opposite of what you see for the x value and then exactly what you see for the y value. It also mentions that it's been vertically reflected and vertically compressed by 20. So vertical stretches, compressions, and reflections are the a value. So if it's been vertically reflected, that means my a value is negative. And if it's been compressed by 20, a compression would be a fraction. So this would be -1/20. Now it doesn't mention anything about being horizontally stretched, compressed, or reflected, which means I don't know what b is. So I would just assume that since we're multiplying, it can't be a 0. I would assume it's a 1. Okay, so if I go to write my equation, there's 2 ways to do it. One where I use all of the numbers. So I could say c of x equals a, so -1/20, times b, which is 1, times x plus h, so plus 6, and then to the power of 5 plus 10. So that's if I just write all the numbers in. Second option is you could write it without the 1, right? Because 1 times anything is just the number. So I could just say it's 1/20 times x plus 6 to the power of 5 plus 10. Okay, we are going to take a look at part D. So part D says a sine function that has a period of 4 pi, an amplitude of 8, and a midline of y equals -17, and a phase shift of 3 pi over 7. So as I'm reading through this, things that jump out at me, it is sine, not cosine or tan, that the period is 4 pi, the amplitude is 8, the midline is -17, and the phase shift is 3 pi over 7. Okay, So my basic equation would be d of x equals a times, and this time the function is sine, so sine, and then the argument is going to be b times x plus h, and then plus k. Okay, so some of these are easier to figure out than others. The period is the tricky part, so I might save that till the end. It says the amplitude is 8. So the amplitude is half the height, which is the vertical measurement of our graph. So the thing that controls how tall or short things are vertically would be our a value. And we said that the amplitude is just the absolute value of a. So my a value is either 8 or it could be -8. I don't know whether it's been reflected or not. It doesn't mention anything about it. It could be +8. It could be -8. I don't really know. The midline is at y equals -17. So the midline on your graph, so that would be down here at -17, is that halfway line on your sine curve, right? What's going to change the midline? Moving it up and down. So this number here gets changed according to whether the graph has moved up or down, which would be k. So in this case, k is -17. The phase shift is 3 pi over 7. That is the first point in the cycle, which basically means this is coming from what has moved my graph to the left or to the right. So if I see that this is positive 3 pi over 7, everything in the bracket is always backwards. So this would be negative 3 pi over 7 as my h value. And then the last part is the b. So the period is 4 pi. There are two ways to figure this out. Number one, you can think about it, right? A sine function normally has a period of 2 pi. What would I have to do to 2 pi to turn it into a 4 pi? I would have to multiply it by 2. This would be 2 pi times 2. When I multiply, that's a stretch. So this would be a horizontal stretch of 2. So a horizontal stretch of 2 would be my b value, and instead of being 2, it would be 1/2. Now, there is another way to do it. There's a calculation that you can do. So there's a formula that says that the period for a sine or cosine is 2 pi divided by the b value. So if I know my period is 4 pi, that's 2 pi divided by b. And then I can try to solve that equation. I would cross multiply. So I would get 4 pi times b equals 1 times 2 pi, so 2 pi. And then I would divide by 4 pi to get b by itself. And 2 pi divided by 4 pi is the same thing as 1/2, right? The pi's divide out, and then I have 2 over 4, and that's the same thing as 1/2. So I personally prefer to just think about it, right? To think, how did 2 pi change to give me 4 pi? I multiplied it by 2. That would be a stretch of 2. So then this would be 1/2. But you can use the formula if you would prefer. It's your choice. So my final equation, I do actually have a number for each of these. The only thing I'm not sure about is whether this is 8 or -8. So I am just going to choose one. I think I'm just going to pick 8, but it could be -8. I don't really know. So I'm going to say this is 8, and then times sine of 1/2 x minus 3 pi over 7 minus 17. You could, if you wanted, maybe put a plus or minus in front because we're not sure if it's positive or negative, but I'm okay with you just picking one. All right, you can join me in the next video to see how to do the next example.